So next we want to have a brief discussion of what is physics anyway. So physics is sometimes called the most fundamental of the sciences, and this is because it is concerned with looking at fundamentally what's going on in the universe. We want to build models to describe the physical world, and these models encompass a wide range of phenomena. So it's the study of motion, forces, heat, energy, sound, electricity and magnetism, light, optics, materials, atoms, nuclei, particles, space-time, stars, the cosmos, and pretty much everything else as well. So we are looking at these different aspects of the universe and asking ourselves why. Why do these aspects of the universe behave in the way that they do? And we try to create models. Often these models take the form of a mathematical equation or principle. And these models allow us to make predictions about, given a certain circumstance, how the universe will behave. So that is our goal. And since physics involves models that often are mathematical in nature, it's important to have hold of some good mathematical tools. So one of these mathematical tools is scientific notation. If we're studying everything from the smallest things in the universe to the very largest things in the universe, we need to be able to express a very wide range of numbers, really, really small numbers and really, really big numbers as well. And scientific notation allows us to do that in an efficient and compact form. So there's a couple of different ways in which scientific notation expresses numbers. If you have a large number, you can see that in scientific notation, you have a number out front times a power of 10 raised to some exponent. And the exponent tells you how you should move the decimal point to express the number in non-scientific notation. So, for example, if you have this large number, if the exponent is 2, that means the decimal point needs to move 2 places to the right if you were to write this number without scientific notation. On the other hand, if you have a negative exponent, that denotes a small number and means that the decimal point needs to move 2 spaces to the left. Now below here on this slide you can see some rules for multiplying and dividing scientific notation numbers. So if you have a couple of scientific notation numbers and you're multiplying them, what you would do is multiply the numbers out front and then add the exponents to get the exponent of the resultant. So you can see that this is our result from doing that, and it's standard to only have one number to the left of the decimal point. So we would need to move the decimal point one additional place and express the final answer in this form. On the other hand, if you're dividing two scientific notation numbers, you would divide the two numbers out front and then subtract the exponent in the denominator from the exponent in the numerator. Now these examples show you how you would multiply and divide scientific notation numbers by hand. If you have a calculator, you can enter the numbers in as scientific notation numbers and then just use your multiplication and division buttons as normal. And if you do not know how to enter scientific notation numbers into your calculator, please see me and I can show you how. Now we'll also be using a lot of algebra and doing algebraic manipulations with equations. So this is just a reminder of some algebra facts. So with natural exponents and logarithms, you should remember from your algebra class that a natural exponent and a logarithm, these are the inverses of each other, and you use one to undo the other. So if, for example, we have an equation like 4 is equal to e to the x, and we need to get at x and figure out what x is, then to undo the e to the, where e is the natural number, we would take the natural logarithm of both sides of this equation. So the natural log then undoes the e to the and leaves us with just an x. And on the other side, when we take the natural log of 4 using our calculator, we get a numerical result of 1.39. If, on the other hand, we have a natural log equation, like the natural log of x is equal to 3, then we would undo this equation with e. Since e to the is the inverse of taking the natural log, e to the undoes natural log and we're left with x on the left-hand side, And then when we take e to the 3, if we put that into our calculator, we get an answer of about 20.1. All right, so let's try this. Here is an algebraic equation, and we want to find a value, a numerical value for x.